Hello to my wonderful viewers. This is Teacher Olumide. I just want to say a huge thank you to every single one of you for following my videos, for liking them, for sharing them. God bless you. I've been overwhelmed with the love. Thank you, thank you, thank you so much. All right, so today we are going to be looking at number bases. And in number bases, there are three basic concepts that we need to understand under it. The first one is we are going to be learning how to convert numbers from base 10 to other bases. Numbers in base 10 are the natural numbers like 1, 2, 3, your natural counting numbers. They are all in base 10. Then the second one, we are going to be learning how to convert from other bases to base 10. And the last one, we are going to be learning how to convert from other bases to other bases. All right, so the first question we have here says, we should convert 29 base 10 to base 2. Now, anytime you are converting from base 10 to other bases, you are going to use the method of long division. So this is how we proceed. So since I'm converting to base 2, that's going to be 29 divided by the 2. All right, so let's take, now for every of our division, we are going to be writing down the remainder. It doesn't have to go perfectly in the number, but every time it doesn't, we'll write the remainder. So 2 in 2 is 1, 2 in 9 is 4, remainder 1. Now the next, we keep using 2. You will keep using the base you've been asked to convert to till you are done. 2 in 14 is 7, remainder 0. The next one we have 2. 2 in 7 is 3, remainder 1. The next one is 2 in 3 is 1, remainder 1. And the next one is 2 in 1. Now, the moment you get to the point where the base can no longer go in the number, you are going to write 0. Remainder, whatever is the smaller one. So 2 in 1 cannot go. You write 0, remainder the 1. And so here will be the answer. So it means that 29 base 10 converted to base 2 is equal to, so you start from the bottom upward. So we have 1, 1, 1, 0, 1 base 2. And that's the answer. All right, so in continuation of our topic on conversion from base 10 to other bases, we have another very simple question again. So solution, we've been asked to convert 815 base 10 to base 6. Now, if you remember the last thing I said in the last class is that anytime you are asked to convert from base 10 to other bases, what you are going to introduce is you are going to be doing the long division. So we have 815. We don't know how long it will be. Base 6. All right, so let's go. Now 6 in 8, that is 1, remainder 2. 6 in 21, that's going to be 3. That's 18. That's remainder 3. In 35, that's going to give us 5. Remainder 5. All right, so we go again. 6. 6 in 13 again, that is 2. Remainder 1. 6 and 13 is 2, that's 12. That's 2, remainder 1. In 15, that is still 2. Remainder 3. All right, so again, 6 in 22, that's going to give us 3. Remainder, that's 18. That will be left with 4. 6 in 3 is going to be 0. Remainder, don't forget what I said the last time. If the number here cannot go in this, you will write 0. Remainder, that's number here, the smaller one, which is 3. And so that's going to bring us to 815 base 10 equals upward 3, 4, 3, 5 base 6. And that's just the simple answer. All right, so in today's class, we want to move to the second segment of number base, which is converting from order base to base 10. Now, the first example we have here says we should convert this number in base 2 to denary. Now, denary is just the English word for the Latin word denarus, which means to group numbers in tens. So anytime you see denary, the question might not state categorically that you should convert to base 10. But the moment you see denary, it's easy. It's just like this base 2. They could say convert to binary. It's indicative of base 2. All right, so how do we solve this question? So very easy. So what we are going to do is that the 11011 base 2. So each of these numbers is going to be multiplying the base. So this first one here, 1 times 2, plus you go to the second one, 1 times 2, plus you go to the third one, 0 times 2, plus you go to the fourth one, 1 times 2, plus you go to the fifth one, 1 times 2. Now on each of the two, you start from 0, the numbering 0, 1, 2, 3, and 4. Or to make it easier, you could put them here so that you don't forget as well. So this is 1 times. Now 2 raised to the power of 4 means 2 multiplied in 4 places. That's 2 times 2 times 2 times 2. And that's going to give us 16. Plus 1 times 2 raised to the power of 3 is going to give you 8. That's 2 times 2 times 2. Plus 0 times 2 raised to the power of 2 is going to give us 4. Plus 1 times 2 raised to the power of 1 is 2. Plus 1 times 2 raised to the power of 0 is 1. So 1 times 16 is 16. Plus 1 times 8 is 8. Plus 0 times 4 is 0. Plus 1 times 2 is 2. Plus 1 times 1 is 1. Now 16 plus 8, that's 24. 24 plus 2, that's 26 plus 1. And that is 27 base 10. All right, so that is 11011 base 2 converted to base 10. Thank you for watching. Do like, subscribe, and share. God bless you. All right, so we have a second example here, and we've been asked to express 556 base 7 to base 10. So just like we said the other time, we are going to follow the same process. So this is solution. So that means I'm going to write 5. So that's your 5. Now this is going to be 5. This 5 times 7 plus the second number, 5 times 7, is going to be each of this number multiplying the base and added together. Then we have 6 times 7, 0, 1, 2. So here we have 5 times 7 raised to the power of 2 is 49. 5 times 7 raised to the power of 1 is 7. Plus 6 times 7 raised to the power of 0 is 1. Now 49 times 5. That's going to give us 245. Plus this is going to give 35 plus 6. And finally, we are going to have plus 35 plus 6 plus 245. And that's going to give us 286 base 10. Very easy. Thank you for joining.